here's hopefully some revision on fractions. So a fraction is made up of two elements. These are a numerator and a denominator. And when we actually turn that into doing a sum, into doing the calculation, those are called a dividend, and the thing we divide a dividend by is called a divisor. The result of that is in a quotient. But the most important ones for today are the numerator on top of the fraction and the denominator on the bottom. Now when we add or subtract fractions, we have to have a common denominator. I know there's been a few bits of confusion around that in terms of whether it's divide or multiply. No. When we add or subtract fractions, the only way we can do that is with a common denominator, so they're out of the same proportion things. For multiplication, well, that's actually the easiest one. We just multiply a numerator by a numerator and a denominator by a denominator. So when we're multiplying two fractions together, multiply the top two numbers together, multiply the bottom two numbers, or in this case, as we're going to move on to today, letters together, and that's your multiplication. Division works very similarly, but if we divide one fraction by another fraction, we flip the second fraction, that divisor fraction, the fraction we are dividing the first fraction by. We flip it, and then we do a multiplication instead. So, here are some examples of that. Right, addition and subtraction, again, we need a common denominator. So, for example, here I have an equation. Well, I don't actually have an expression. Okay, 2x over 5x plus 4 over x. Now, I can't do anything with those until they have a common denominator, because the 2x is a description of out of 5x, and the 4x is a description out of x. So I'm going to get them to have a common denominator, and I'm going to do that by multiplying the fraction on the right by 5. I'm going to multiply top and bottom by 5. So that's going to give me 2x over 5x plus 5 times 4 over 5 times x. That gives me 2x over 5x plus 20 over 5x. And now I can add those two top pieces together and get 2x plus 20 all over 5x. Another example, x over xy plus x over y. Again, I can't do anything with these until I have a common denominator. So here, I've multiplied the fraction on the right, top and bottom, by x. Again, you have to multiply both the top and the bottom, both the numerator and the denominator, by the same thing. Otherwise, the proportions change and you've just changed the meaning of that fraction. It won't equal the same thing when you multiply it out. So I've multiplied the second fraction there, x over y, by x over x. Multiply top and bottom by x, and that's going to give me then x over x plus y plus x squared over xy equals x plus x squared all over xy. Now, multiplication. Again, in this case, what we do is we multiply the numerator by the numerator and the denominator by the denominator. This is actually the most easy, I think, operation with fractions. So, for example, here, if I want to multiply x over y by x over y, I just multiply the two together. X times x on the top gives me x squared, y times y on the bottom gives me y squared. So my final fraction is x squared over y squared. I want to multiply x over y by y over x. I can say actually that's the same as x times y over x times y, and of course anything divided by itself is 1. So that's what I've got, equals 1. A slightly more complicated one now. X minus 1 over x minus 2 multiplied by x over y. I multiply the numerators together. I put x on the outside of that bracket. So I've got x, open bracket, x minus 1, close bracket, all over y on the outside of the brackets, x minus 2 on the inside of the bracket. And they're going to multiply both of those out. And that's going to give me x squared minus x on the top here, and at the bottom I multiply out this process to give me xy minus 2y. And then I'm really stuck. I can't do much else. I could, if I wanted to, split out this fraction and say it's x squared over xy minus 2y minus x over xy minus 2y, but it doesn't really help me do anything else at this point. But just to make the point that we can do that. We can split the numerator, keeping the denominator the same. It doesn't change the meaning of that information, and if you doubt that, put some numbers in there. Put numbers into x and y and see what happens. But one thing we can't do is ever split the denominator. So make sure you can realize that you can split that numerator up. So I've still got x squared minus x, and as long as I keep them over the same denominator, I don't change the meaning of that information. So a couple of examples of division. Again, we're going to use the same operation we use for multiplication, but first we have to flip the divisor fraction, the second fraction. So in this case, I've got x over y divided by y over x. I'm going to flip the second fraction, that's the fraction on the bottom there, the divisor, and that's going to give me x over y times x over y, which of course, just as we've just done, is going to equal x squared over y squared. Slightly more complicated one. X plus 1 over x plus 2 divided by x plus 1 over x plus 2. That second fraction, I'm going to flip it, and we're going to change the sum to a multiply. So this becomes x plus 1 over x plus 2 multiplied by x plus 2 over x plus 1. And that gives us this final result here. X plus 1, x plus 2 over x plus 2, x plus 1. Now I could at this point multiply out the brackets if I wanted to, but I've noticed something. Actually, we've got common things on top and bottom, and they cancel. Because x plus 1 divided by x plus 1 is 1, anything divided by itself is 1, I can eliminate that and give myself x plus 2 over x plus 2. But that's still two common elements on top and bottom. X plus 2 divided by x plus 2 is 1, because anything divided by itself is 1. So always keep a watch out for those, because they can be really handy to eliminate unnecessary sums. There is something else I wanted to remind you of for the fractions that I haven't gone over yet, and that's this. As with the linear terms, when we've looked at applying a power to things inside brackets, we said that we have to apply a power to all of the elements inside the bracket. So if we had AB inside brackets squared on the outside the brackets, that's the same as A squared, B squared. We have to square everything inside the bracket to get rid of the brackets. The same is true for fractions. Here I have an example. A over B in brackets to the power of x is the same as a to the power of x over b to the power of x. The only way I can get rid of those brackets is to make sure I apply the power x to every element inside the bracket. So for example, I've got some example here with numbers. I've got 4 over 2, all squared, so 4 over 2 inside the bracket, squared on the outside. And I'm saying that that is the same as 4 squared over 2 squared. And just to show that's true, I've developed that sum. So 4 over 2 is 2 squared. And on the right-hand side, 4 squared is 16. Divided by 2 squared is 4. And both of those, 2 squared and 16 over 4, is going to give me the same quotient, answer 4. The other section of today's mini lecture is transposition. This is about rearranging and changing formulae, changing equations. But we have to make sure that when we're changing them, we aren't changing the meaning. We have to make sure that they're still true to the original formula or expression we were first given. That means we do that by applying the same process to both sides of the equation every time. So we can add the same quantity to both sides, we can subtract the same